be live. So when you click on this fella, it will tell you essentially what you need to do. So I'm just going to talk through this, but you don't need to write anything down because you can go here and look at it yourself. But make sure everybody is aware of what is expected of you. Final exam is going to be on tomorrow, 7 till 10. It will become visible at 7 o'clock. So when you go to WebAssign at 7:01, it'll appear, and it will close at 10, unless you have an extension. And some of you have an extension, then you will be clicking on the WebAssign final exam called extended exam instead. So if you don't know what I'm talking about, then you ain't that person, right? So you will just go to the normal one. You got 3 hours to complete it. It's completed. I've written it. Written it. It's really not the word. Somebody else has written it. I've chosen the questions, and it's chronological and it's comprehensive. So the first question you will see will be something to do with partial fractions, and the last question you will see will be something about finding T3 of X Taylor series, something like that. What else as we go through this? There's going to be a Zoom meeting during that time, so could I ask you to make sure you have your Zoom camera on so I can check it's you and not your big brother that's doing the test. And you're not allowed to communicate with any human being, either virtually or through email or through person. So that includes blogs, tutoring blogs, help sites, and anything like that. And also software, with the exception of that is that you're allowed to use Desmos or GeoBra for 3D curve sketching, for instance. And Surface Sketch. And what else? I do expect you to see your work. There's a fair number of questions, and you've already seen them in your homework. Here is a series. Does it converge or diverge? And there's a dot that says converge, and there's another dot that says diverge. You don't just click on one of those 2 dots and move on. That will get you 0 points. I need proof. So that's one example to give you. There are lots of questions where you can show me proof of whatever it is, especially in sequences and series. Anytime you can possibly think of working, give me that working. If it's partial credit you're looking for, that's very important. If you get it wrong, but I see the working, you're going to get most of the points. If you get it wrong, but I see very little working or not enough that I can see what has happened, then you're not going to get as many points. So you have to be careful. What are you allowed to do? Basically, you're allowed to use anything that you want and that's physically written or a video. So any PDF you've got, any notes you've got, anything along those lines. And same word of caution as before. This final exam is not testing your ability to find things you don't know. It's meant to be testing what you already know. If you have to look up everything in 23 questions, and you have to watch a 5-minute video to remind you how to do it, or you need to spend 10 minutes going through and finding some PDF and then, figuring it out, you won't get the exam finished in time. In which case, you may do really well on half the questions, but getting 50% isn't going to help you. So you have to be very good with your time management. Anything that you know that you're going to have to spend some time looking up, I strongly suggest that you leave that guy alone and do it when you've finished all the other ones that you can. And that's probably going to get you more points. That would be my very strong suggestion. Oops, excuse me. So, can't say this often enough, I expect to see working. If I don't see working, I'm going to be really suspicious, especially if it's something that I know takes 5 minutes to do and you can't possibly do it in your head. And even if you can possibly do it in your head, you will still show me the working, right? That's the deal. So if I see 42 and it appeared from nowhere, I'm going to assume that you use some software like Mathematica or whatever and found out what the answer is and just wrote down whatever it said. And that will get you 0 points. So we don't want that. Right, the usual, when you're finished, scan it. I've given you some links to Adobe Scan, but you can use whatever you've done before and upload it into Canvas, and there'll be a Canvas page waiting for you. So that's that guy done. So upload final exam working here. That'll be the link that you'll use for your final. Now, told you there's going to be extra credit. It's here. Due midnight tonight. Is this on the screen? Will I have to talk through it? On the screen, can you see it? Okay, so basically what you're going to do here is answer or do these 4 tasks. Confirm your email. Seems a little bit pointless, but I have a spreadsheet with emails, and most of you are fine, but some of you, for some reason, have been telling me you don't get stuff from me. So when you confirm your email, I'm going to check with the email I'm using and change it appropriately if it doesn't match. You're going to confirm the number of days that you have missed. You're going to tell me, did you complete the extra Canvas or not? That's so that when I check, I know. The reason I cannot find any information on the Canvas extra credit class is because you never did it. It's mostly for my benefit. If I know that you've done it and I can't find it, then I'm going to search through the email and the stuff that tells me about it. And then you're going to answer some questions too. And you're going to put the work in, hopefully in here. And then when you're finished with it, you're going to upload it into its own little place, which is there. And that'll give you a chance to practice copying something and uploading it before tomorrow. So you've got until midnight to get that to me if you choose to do it.
Mr. Robertson,
yes.
Where's the extra credit Canvas class? Because I don't ever recall, like...
It was in the syllabus. It's called something like Canvas. God, it's got a weird name. Is it called Canvas Intro to Canvas 95 or something? Somebody help me out here. What's it called?
Yeah, it's Intro to Canvas 97.
97.
It's all spelled out in the syllabus.
And it's in the syllabus, so that's where you need to go if you want to see anything about it.
Also, right. where do we find the number of days we have missed?
You need to know in your brain, I have missed no days. I remember missing a Tuesday. You will tell me, no, I don't need to know it was 14th of July. I just need to know I've lost 3. Because if you say you've lost 3 and I think you've lost 4, then we can have a discussion about, which one it is. But it's just, I could quite easily just not ask you that and go by what I believe the answer is, and then you're going to turn around and say, oh, I turned up late that day, that's maybe why you didn't get me, or something. And I want to make sure that my number and yours, and I'm being generous, if we differ by 1, I'm picking your number. So if I think you're missing 4, but you tell me you're missing 3, I'm just going to say I missed, I did it early, late, and I skipped you somehow, right? And that's going to be how I'm going to check that.
One question about the upload for the extra credit piece. I'm looking at Canvas right now, and it's showing a due of 11:59 a.m. today.
Oh, naughty. Thank you for catching that.
Cool. Right. Just making sure so it's actually due midnight, and that just typo. Awesome.
It's due midnight. I'm looking at. Let me check it. Students have ready some of you have beaten me to the gun. It says 11:59 p.m. here.
Yeah, look above it.
Oh, it says a.m. there. You're right. Caught. It should now be midnight, like I said. That was well caught.
It's updated on the dashboard side as well on our end. So awesome. Thank you.
Right, cool. If you come across any things like that, I mean, AM, PM's an easy mistake. Shoot me an email and I can fix it. Is that any more questions about what we've been speaking about right now?
How much is this extra credit worth?
It's essentially worth, how am I going to phrase this one? Do you know your homework? Each section in your homework is worth technically 100 points, but they all get averaged out, so it's not really 100 points that way because whatever. Each extra credit is the equivalent of doing 50 points in a homework. So if you did 2 extra credits, it would be 100 points added onto your homework score. So it is possible for you to have more than 100% in your homework grade, because that's just where I'm putting it. I'll just pick, I don't know which one I'll pick. I'll probably pick the first homework and just add the points to that one. That's the easiest way for WebAssign doesn't take kindly to adding stuff that's not homework that they made. So I'll just do a workaround. I'll just add it to that.
Awesome.
So when you get your report, if you ask why did I get a 1.8, not that anyone is ever going to ask me that, right? Because you're all going to get 4.0s or at least try. You might find out that your homework grade is 102%, and that would be because of your extra credit.
I have a quick question about the Gen 95. So if we've previously completed it for another class,
just get a certificate and send me it. Get a copy of it.
Okay.
That's all I need. You could probably send it to me in the same, maybe not. I've never tried this. You could send it to me to the same link that you do assignment 2 into, credit assignment 2. And that way I'll have 2 PDFs hopefully, and I can just check it that way. That may be the easiest way for me to do that. Okay, any other questions? Okay, so what I want to do now, if I can find the right page. Of course I can't. That would be too easy. We're going to look at 1111, and a couple of things in 1111 that are tricky, I guess. That's the word I'm looking for. Got some chat questions here. Yes, you can still send the Canvas certificate. And I've answered Grace. And we are good. Okay, so let's jump right into finding T2 and T3 of X, which is basically, instead of finding the power series for a function, which can be and is extremely difficult, except for a few special cases, what we typically do in the real world is that we only find some of the terms. So imagine I have a function, well, not imagine, here it is. Imagine I have a function like x e to the x, and I'm interested in finding a T3 of x. And I'm interested in using it between, let's keep it positive, between 0.8 and 1.2. Well, question A might well ask you to find T3 of x. And then question B is going to ask you to find this guy who is new. What I want to show you then is how you go about this, and then tell you a little bit of good news. Right, let's take this fella here. T3 of x is, let's have this fella centered at 1, just to be different. then it's going to be f of 1, f dashed of 1, x minus 1 to the power of 1 over 1 factorial. Then the second derivative at 1, x minus 1 squared over 2 factorial, plus the third derivative at 1, x minus 1 cubed over 3 factorial. And in general, that's what all T3 of x's look like. You find the first, second, and third derivative evaluated at a, and if it's centered at a as it is here, x minus 1 squared, x minus 1 cubed. And we are expected to do a little bit of tidying up, but we're not expected to FOIL that out and make a cubic. So the final answer looks like combinations of various powers of x minus 1. So let's show you the process of how you go about it. There's that guy, right? So I'm deliberately picking an ugly one because I figure if I do an ugly one, the rest will be easier, right? I'll find its derivative. I'll find its second derivative. I'll find its third derivative. And I'm just doing that because I did one like that on Thursday, and I just, you know, you're using the product rule and you're doing a whole load of terms, but can you trust me, it ends up being that when you're finished. And then you do a product rule and it ends up being that, and you do a product rule and it ends up with that. This is done quickly because I happen to know the answer, but you can check it yourself. Product rule, product rule, product rule. So far, so good. Any questions about that? Be comfortable? Now I need to find f of 1, the derivative at 1, the second derivative at 1, and the third derivative at 1. You plug it in here, you get 1 times e. You plug it in here, 1 plus 1, so you get 2 times e. You plug it in here and you get 1 plus 3, you get 3 times e. And you plug it in here and you get 4 times e. So far, so good. Now you put that package together and you get f of 1, which is e, plus f dashed 1, x minus 1 over 1 factorial. The second derivative at 1, x minus 1 squared over 2 factorial. And the third derivative at 1, which is this fella, x minus 1 cubed over 3 factorial. Now there's not going to be too much tidying up, but you should try at least an attempt at doing whatever you can. Can't do much with that. 1 factorial is 1, so I would write that. 2 factorial is 2, so I'm really not going to get much out of that. And 3 factorial is 6, so 4 over 6 gets me 2/3. And that's that question finished. Now, if you wanted T2 of x, it would be that bit, right? I guess if you wanted T1 of x, you would get that guy. I'm not sure if I'm winning here or losing. Are you comfortable with this process of how I got T3 of x? Okay, good. Thumbs up. That's what I needed to see. I needed some visual clues here. Okay. So, what would your answer look like if this was a test question? It would look just like it would be in the homework. It would give you a function centered at 1. It gives you this little interval. This just says we're only going to use this function for values of x between 0.8 and 1.2. And typically, you'll notice that 1 is right in the middle of that interval. Here's a T3 of x. We haven't talked about this guy yet. Right? Now, essentially, this fella is the error function. Now, I'm going to go through the process of evaluating this error function. And it's a long, quite complex process. But once I've shown you it, I'll then tell you something nice. Okay. The remainder function, R3 of x, that's another name for it. The remainder function R3 of x is equal to m x minus 1 to the power of 4 over 4 factorial. The absolute value of it is the absolute value of that. M is a number. N is the maximum value of the fourth derivative of x for x in this range. So whatever you got here, m is the maximum value of the fourth derivative for values of x in this range. So how will I find R3 of x? Well, first thing you have to do is you have to find the fourth derivative. And the fourth derivative happens to be that guy. Then you have to find what is the maximum value of this fourth derivative, which is this function, if you're only going to use values between 0.8 and 1.2. So here goes. That's the maximum value. Where on earth did the 1.2 come from, and why am I using that, not any other number?
It's the maximum on your range.
Yeah. So when you're looking for m, it's either going to be the 0.8 side or the 1.2. In this case, it is definitely the 1.2. It's kind of obvious to tell that wouldn't this be the biggest in this range when x is at the 1.2 side. But can you imagine it was 4 over x squared or something, right? Can you imagine that was a derivative? Then wouldn't the 0.8 generate a bigger number, because 4 over 0.8 squared is bigger than 4 over 1.2 squared. So you're going to be choosing one or other of the endpoints typically. Now this guy here is not expected to be left as an exact value. So I'm just going to do it as a calculation. So it's going to be 1 plus 4 times 1.2, close the brackets, times e to the power of 1.2. And I'm looking at 19 point, well, let's just call it 19.3. Which means that R3 of x, right, the absolute value of it is 19.3 x minus 1 to the 4 over 4 factorial, 4, 3, 12, which is 24. And we are being asked to find the maximum value of this remainder error function. And it has to be in the same range as here. Right, that's a number, that's a number. This has got some x's in it. What value of x is going to generate the biggest answer if x can only be in this range here? Or at least tell me how I can find it.
Well, generally you'd use either the top or the bottom of that domain there, but in this case it would be the top.
Right.
Pretty obviously, but that's obviously dependent on the function we're evaluating.
Correct. So in this case, 1.2 is what? 0.2 away? over 24. So I'm now going to do that calculation. 19.3 times 0.2 to the power of 4, which is that, divided by 24, which is that. And I just about got enough room in here. How about 0, 0, 1, 3? So this remainder function is 0.0013. Well, you might think, what is this? What's the relevance of this number? What have I found? Well, what I have found is that if you use this fella here, the T3 approximation to f of x, if you use this guy here to represent this function, and you only use values of x between 0.8 and 1.2, you are guaranteed that your answer is correct, plus or minus 0.0013. Very roughly, it's good to 3 decimal places. So what that allows us to do now is we can approximate a function by T2 of x, T10 of x, whatever we like. Then we go through this horrible process, because it's very time consuming, to get that guy. And once we know that guy, can't we then say, if I use this, and as long as x is between here and here, whatever answer comes out of here, it's good to 3 decimal places. Right? Basically a tolerance. So what's the good news? We are not going to do any R3 of x's. In the sense, I am not going to give you any of those in the test to the final. Now, there are homework questions that have R3 of x in it. And you're just going to put, I don't know, you're just going to put 42 as a placeholder. And I will go back and fix it and give you the points for it, right? So what you're now going to do is find T2 of x, T3 of x, that part of the process. This here is going to be, well, a couple of reasons. One is it's too long. If I gave you a couple of these, you'd be in, 20 minutes would disappear very easily. So you're, say again?
I would just like a little bit of clarification. Whenever we were looking at the R3 of x, why did we go with the fourth derivative again?
It's the magic of that's what you do. So see if you want T2 of x, right? See if you can, R2 of x will have the 3 guy in it. So, I mean, in general, Rn of x will be m x minus, well, I guess 1 to the 5 over 5 factorial. And I'm saying 5, it will be n plus 1. So part of the magic is you use the next guy. Analogy. Remember when we did alternating series test? See if you did up to S4, which I guess is like T4, right? Wasn't the error the 5th term? So if you use T3 of x, the error is contained in the 5th term, the one you didn't use. And that's pretty much the analogy that's going on here, right? R3 uses the 4th term. It uses the 4th derivative. R2 would use the 3rd derivative, and so on. So that's just part of the magic. You're just told that's how it works.
Thank you.
Right.
So I got another question about
Go
this
for it.
process. So when you're finding M,
Mm-hmm.
Do you find the largest value of the absolute value of M within that
Yes.
range? Okay.
Yes.
So even if the lower
very
value
big
gives
negative,
you a technical,
If there was a very big negative number, that's the one you would use, because the absolute value of it would be a very big positive number.
okay, that makes sense.
You'll also notice, if you did want to do practice these for your own benefit, but I would wait until the final was over, that almost always doesn't occur at the ends.
Yes.
So you can check that quite easily. Now,
And one further clarification about what you said on this with respect to which derivative you use. Where, you know, the fourth derivative is the one that works in this function to get a certain level of accuracy, but other functions you may need even a higher derivative than, if depending on the function that we're talking about, or is that more of
Yeah.
a general rule?
Where are we going with this? Right, R3 uses the fourth derivative, right? That's a generic truth. I can imagine, now that you said that, there are some circumstances where that derivative is zero. You know, like the sine function, every second term disappears as zero. So I guess in that case, you would have to move to the next one again until you got a non-zero derivative.
But I guess my question was, though, is that okay, so if you're looking for R3, it's the fourth derivative, but I mean, I think maybe we're just talking at cross purposes in terms of the premise of the question here, but this would only be if you're asked for R3, but we're not talking about a question that's asking you to get accurate to, you know, X or Y decimal places.
Correct. You're only being asked to find R3 of X and its maximum value. Yeah. Now, this is just a little bit of tidying up. If you do X e to the X, the original function, hold on a second. It's Maggie. Evidently, I'm ignoring her, so I have to let her in. So that's the first function. Now, this one's going to take me a little bit of time, so hopefully I don't screw up too much. There's E. And then I'm going to add 2E brackets X minus 1. And then I'm going to add 3 halves, which I'm just going to call 1.5 because it's less work. E to the X, take away 1 squared. And then I'm going to add 2/3. I'll stick on a bracket. 2/3 E brackets X, take away 1, close brackets, cubed. And then I'm going to go to the window and I'm going to go 0.8. No, I'm not. I'm going to go to window. I'm going to go 0.8 on one side, 1.2 on the other. And then I am going to go zoom 0, which is zoom fit. And we should hopefully find out that I didn't screw up anywhere. That is X e to the X. And this guy is now T3 of X. Do you notice that there's no difference? There might be a little touch at the beginning there where it's a little bit thicker. Is that a good justification that this method is very good at approximating X e to the X, at least within that range? Can you see why the error is so small? No matter what value of X I choose from here to here, could you imagine that none of them are more than 0.0013 away from the exact value? And that is basically the gist of that process. So what I'm going to focus now on is the only bit that you need to worry about, and that is finding T2 of X or finding T3 of X, right? Anything else in the homework after that ain't happening, right? You just need to say whatever. I'm assuming you can do the calculator bit, right? You know the first function, you know the second, you could find the difference between them. So let's go looking at homework questions. That's probably the best choice. And
So on the final, are you not going to ask us, or not going to require us to do the compare the graph to R3 and T3?
correct. I'm going to ask you to just find T2 of X or T4 of X, that piece of the puzzle.
Awesome.
Right. Now, if there is a graph one, because some of them I can't avoid it, if there is a graph one, I'm just ignoring that part of the question if it happened. You're making me think that I might have had one. But they just give you 4 pictures and you pick one, so it wouldn't be hard to fix. So just pick one at random if you feel worried about it. It's hard for me to suck out the R3 from this section because they have it almost in every question. But I won't be doing it. I won't grade it, and you won't lose points if you write 42 in it, right? You're just going to ignore that part of the process. So I'm going in right now. Hopefully. Okay, let's start with a question. Here is a function. In this function, a equals 1. And what else do we know? N equals 2. I don't need to know why you're telling me n equals 2, because the question is pretty obvious. N equals 2 because they're asking you to find T2 of x. So this is a Taylor series centered at 1, T2 of x. So here is f of x. Here is its derivative. Here is its second derivative. If you're doing T2 of x, don't you only need to go as far as the second derivative, right? This fella, multiply by the power, reduce it by 1. Multiply by the power, reduce it by 1. Since I am not looking for patterns here, do you notice I just multiplied things together as is? I'm now going to find f of 1, which is that guy, which is 1. F dashed of 1, which is that fella. And the second derivative at 1, which is that fella. Are you all happy with 1 to the power of -7 is just 1, so 30 times it is 30. Now to get T2 of x, in this particular version, it's going to be f of 1 plus f dashed of 1, x minus 1 over 1 factorial, plus the second derivative of 1, x minus 1 squared over 2 factorial. And this is a 1. Okay, I'll put it in as -5, x minus 1 over 1 factorial. And then it's 30, x minus 1 squared over 2 factorial, which is 2. And I get 1 minus 5 of these guys plus 15 of these guys. Are we comfortable about that process of generating T2 of x for this function centered at 1? Would you agree it's got a nice process to it, right? You just kind of follow the process and you'll be fine. Let's try square root of x. And centered at 4. And we're being asked to find T2 of x. So this is basically like question 3. That was like question 2. I'll start with my function, but I'm going to call it x to the power of half. Since I know I'm going to be doing lots of differentiation here, it just makes sense, doesn't it, to convert it to a fractional power. Now I need to find its first derivative, multiply by the power, reduce it by 1. I need to find the second derivative, multiply by the power, reduce it by 1. This guy is the square root of x. This guy is 1 over 2 root of x. This guy is -1/4 of the square root of x cubed. And the reason I'm writing it like that is hopefully so I don't screw up when I evaluate the derivative at 4. So that becomes the square root of 4. That becomes 1 over 2 times the square root of 4. And that guy becomes -1 over 4 times the square root of 4 cubed, which is basically 8. So you get -1 over 32. You need exact values for these questions. You aren't allowed to tell me at 0.01625 or something, right? So to be able to do exact values, don't you have to know how to convert these to a form that's going to make exact values obvious? If you just leave it like that and you plug 4 into the calculator, you probably won't get -1/32. If I go -1/4 of 4, well, it helps when the thing's on. So if I go, just want to show you why you can't really rely easily on the calculator. So that's -1/4. I'm going to multiply it by, put a bracket around it for safety, 4 to the power of -3/2. Do you see that that isn't an exact value of anything? You see the ugly decimal. So you're going to have to do some baby algebra here. So what does T2 of x look like? Well, it's going to look like f of 4, f dashed of 4, x minus 1 over 1 factorial, plus the second derivative at 4, x minus 4 squared over 2 factorial. That's a 2. This guy's a quarter over 1, so you just get a quarter of this fella. This guy's negative. This is 2, so you're going to eventually get that fella. And that's T2 of x. Great. Well, let's do something. I would like an estimate of the square root of 4.4. So I'm going to use T2 to do that estimate. So it's going to be 2 plus a quarter of this guy is basically 0.4. So it's a quarter of 0.4. Take away 1/64th of 0.4 squared. So I have T2 plus 0.1, take away 0.4 squared, divide 64, and it looks like I get the answer 2.0975. Okay, that's what my T2 tells me it is. If I go to the calculator and do the square root of 4.4, I get the answer 2.0. That's pretty good. 9. That's pretty good. 7.6. Would you agree that T2 is doing a pretty good job of the square root of x? I mean, what's this guy? This guy's good to the third decimal place and most of the fourth. And it's just using a T2, a quadratic approximation. Any questions about this process? How you find T2 or T3? No questions? Are we good? Here's something. If you do T1 of x, right? At any given value, let's call it A. That's the general formula for it, isn't it? If I tidy it up just a tiny bit, should call that A, by the way. Do you recognize this guy? I'll have to hit the spacebar for you say. Does anybody recognize f of A plus f dashed of A x minus A from Calc 1? Last chance. It's a linear approximation function, very often called L of x. Basically, isn't that a straight line? Do you know T2 of x has another name? The quadratic approximation of a function. T3 of x, the cubic approximation of a function. So you basically tell people that you're approximating a function, and you're also telling them in that description whether you're using a straight line, a quadratic, or a cubic. That's pretty cool, isn't it? So if you ever wondered where did linear approximations come from, that's one way you can think about where they came from. Now I'm zooming down a little bit here. I'm going to pick something a little bit different. 6 is nice and different. The function that we're going to do is got a log in it. And we're going to, there's not a lot of imagination here. Either 0 or 1 seems to be the going rate for the center. And we're going to find, in this question, T3 of x. Okay, so that's a little bit more work. So let's say we got the process set up. You find, in this case, won't I find all the derivatives up to the third? And then I'll evaluate them at 1. And then I'll just do this formula a little bit further. So, first derivative of a natural log is that guy. But if you want to differentiate that guy, you probably should write it like that. The second derivative then is multiply by the power, reduce the power by 1, and then remember to multiply by 2. So it's a chain rule. And the third derivative is multiply by the power. So -2 times -2 gets you 4. Reduce the power by 1. And then remember to multiply by 1 more 2. And that's why there's an 8 there. We can then evaluate all these functions and their derivatives at 1. You plug in 1 here, you're going to get natural log of 3. You plug in 1 here, you're going to get a third. You plug in 1 here, you're going to get -2 over that guy squared, -2 over 3 squared. You're going to get eventually -2/9. If you do this guy at 1, you're going to get 3 cubed in the bottom. 8 over 3 cubed is that guy. So you might want to check those, but that's what I believe the answer is. So T3 of x is going to be the function evaluated at 1. The derivative at 1, x minus 1 over 1 factorial. Then you do the same thing, but you use the second derivative over 2. And then you do the same thing one more time, but with third derivative. Now this guy is a log of 3. This guy is a third. That's 1. So a third over 1 gets me a third. This guy is -2/9, but that's also 2, so that gets me -1/9. This guy is 8/27. That is a 6. The 6 and the 8 will partially cancel. What will it cancel? It'll give me 3. It'll give me 81 and 4. So I believe you get 4 over 81, but you may want to check that later. That's all we need to worry about, is to find that guy. couldn't I find, not that I would ever attempt to do it by hand, but couldn't I find T30 of X? You know, give me a day or two, I could probably do it. Pay me enough money, maybe I'll do it, but I'm not going to do it. So for practical purposes, by hand, what, 2, 3 maybe, no, maybe 4. Something quite manageable would work, right? But don't do anything that you wouldn't do it by hand if it was T30. Wouldn't you use Mathematica or something? But you could say, as we do always, but I could get the answer by hand. I just don't want to because I know how to do it by hand. It's just time consuming. It's not difficult. Okay, 2 more of these guys and then I'm going to call this section done. So this is similar to 8. As always, no imagination whatsoever. They're centering at 1 again. And we're going to be asked to find T3 of X. I'm going to change it to T2 of X. It's the same process, it's just longer, right? If they do 3. So, f of X is this guy. First derivative coming up. What's the derivative of an inverse tan? You can't keep going to look for things. Some things you should just have at the tip of your tongue.
Isn't it 1 over 1 plus x squared?
Okay, so it's going to be, you're right. So it's that guy. Now, since I'm only going to do it to the second derivative for convenience, I still need to differentiate this 5 over 1 plus x squared, right? There's 2 ways I could do this, both work. One of them is, couldn't I just do a quotient rule where 5 was the f and 1 plus x squared was the j, and that would work? Or, couldn't I rewrite this and do a chain rule? So I'm just going to choose to write it like this. This is the same as that. And do a chain rule. So you multiply by the power. You reduce the power by 1. And then you differentiate by what's inside. So you end up with negative 10 and an x over 1 plus x squared squared. So f of 1 is 5 times the inverse tan of 1. What number is the inverse tan of 1? And we don't want a decimal off your calculator. What's the exact value for it? Inverse tan of 1.
Pi over 2.
Almost. You're 90% there.
Pi over 4.
Yep. So you get that guy. For this one, the first derivative at 1 is just basically plugging in 1 there. So you get 5 halves. And for this one, the second derivative at 1 would be negative 10. Okay, what's that? 1, 2, 4. Negative 10 over 4. Negative 5 over 2. So T2 of x is going to be the function at 1, derivative at 1, x minus 1 over 1 factorial. I wish there was some questions where that was 2 or 10 or just something, in case you get into the bad habit of thinking it can only be 1. Right, the first guy is 5/4 pi. This guy is 5 halves over 1, so it's still 5 halves. And this guy is negative 5 halves over 2, so that's negative 5/4. And that's your T2 of x. So you're going to be doing a lot of differentiation here, right? Plugging in numbers, finding exact value of derivatives at 1, putting them into here, making it look pretty. Last question. And this one is like 9. The function we're going to do it to is cosine x. And at last, centered at a number that's not 1. And we're being asked to find T3 of x. Okay, here it goes. Not the hardest, thankfully, derivative to do. Differentiate a cosine, you get a negative sine. Differentiate a negative sine, you get a negative cosine. Differentiate a negative cosine, you get a positive sine. Evaluate all those guys at pi upon 2. Okay. The cosine of pi upon 2. What number is cosine of pi upon 2?
0?
Yep. And then it's 1. And then it's 0. And then it is 1.
Shouldn't your minus sign of x be -1?
Let me check. Thank you. Yes. Now, put that together. T3 of x. The value of the function at pi upon 2. The derivative, first derivative. Same thing with the second derivative. It's going to be really squeezed. If you can't read that last one, you can guess what it should say. Right, we're going to get 0, so I don't care about the rest. I'm going to get -1 x minus pi upon 2 over 1. Don't care about that, it's 0. And this guy's going to be over 6, so you're basically going to get 1. Why did I put 4? This guy is going to be 6, 1/6. X minus pi upon 2 cubed. So forget about the zeros. We are done. So if I gave you any reasonably normal function, right, not some ridiculous messy thing with 2 levels and that, would you feel comfortable about the process of finding T2 of x or T3 of x at e equals 0 or 1 or pi upon 2? Feel comfortable with that? Right. And anything else that may or may not be asked, you're just going to ignore, right? You're going to put 42 or something just to fill the box up. Okay, well, I think we should open it up to just general comments, general topics. What do you want to know? What do you want me to go over? Start chucking questions at me.
I got a quick question. So when we're doing power series and we've come across a function that looks like it can be plugged in, can we just show the other function and then plug it into the other function? Like, how would you like us to show our work for the plug-in type power series?
Right, there are 2 distinct, well, there's probably 3. Let's start. There are, my brain is telling me there are 3. Version 1, they give you a function. I'm picking a nice easy one because I can rattle off the answer. And they ask you for the full power series. And this one happens to be That guy, right? You can't just write that in, because I could go to the textbook and you'll find that guy ready to go. That guy, you have to do the first, second, third, fourth derivative, and then you have to convince me that you know that guy's 1. Well, it wouldn't be much, because e to the x is e to the x all the time, but you'd have to do that. That would be create the entire power series. Now, there's a different version of that same question. A guy that looks like that. They're still wanting the full power series. You will not do this by finding the first, second, third, fourth derivative and looking for a pattern, because trust me, you'll probably never find it. In these questions, what you're going to do instead is that you're going to use that guy as your building block. And then you're just going to do substitution. So if I wanted to do this guy, wouldn't it be x times sigma n equals 0 to infinity? And e to the x is this guy, so e to the x cubed is this guy, but with the x replaced. You will recognize this question because in the ones I've seen, don't they have a little link where you click it and it tells you who e to the x is and a few of the other guys, and then you just use that guy. In other words, you use this fella to generate that. In this case here, when you're finished, you have to write the answer in its pretty format. It's still point, right? Which is what that would eventually become. Now this one, you have to go through the entire first derivative, second derivative, nth derivative at 0. And then, you know, the general formula that you're going to use then is the nth derivative at 0, x to the n over n factorial. Now for e to the x and all of these 1, that's why you get this answer. But in some questions, they have, you know, different values. So far, so good. Now, if they want you to do it, they will have a, I can't remember the phrasing, but it's something like use table from here, and then they have a little link and you hit the link and it takes you there. So you'll know you'll be doing that question because of this. There'll be a link that you hit that'll tell you this fella, then you can use it. If there is no link, then you have to do it version 1, which means you're going to have to generate the first, second, third, and fourth derivative, typically at 0, to see what it's like. So let me try this one. Normally, you should see a pattern by the third derivative, unless it's really weird. Would you agree that's the first derivative? Now, if you get the second, don't call it 9. If you call it 9, you'll never get a pattern. Call it 3 squared. So far, so good. Then plug in this case, 0. So what you're going to get here is 1. The first derivative at 0 is going to be 3. The second derivative at 0 is going to be 3 squared. And the third derivative at 0 is going to be 3 cubed. If you see enough, shouldn't you be able to generate the nth derivative at 0? First derivative is 3, third derivative is 3 cubed. What do you think the pattern for the nth derivative at 0 would be?
3 to the n.
And see that guy? You plug him in there. So now you've got n equals 0 infinity, 3 to the n, x to the n over n factorial. Now you've proved it. When you do, right, when you do these kind of questions, what's the word I'm looking for? Increasing powers of numbers are quite common, but isn't there one that looks like this? And when you see that, what should you be thinking as part of your n through to 0 thing? Factorial. right? Now, if in a nice world, everything will be n's, right? In not such a nice world, couldn't that be n plus 1 factorial and this be 1 shy? So you sometimes have to tweak it, right? The fourth derivative might not be 3 to the power of 4. Couldn't the fourth derivative be 3 to the power of 3? Or 3 to the power of 5? Or I don't know, 3 to the power of something, right? Where you have to tweak it. And the fourth derivative might not be 4 factorial, right? It might be 3 factorial or 5 factorial. So there will be some adjustments sometimes that are necessary. Did that answer? Well, I think that answered your question.
Yeah, yep. So basically, if it has a link, use the comparison or
Yeah.
plug in. If it doesn't, do the whole thing.
Yep,
Got
very
it.
much. Would you? My other thing was, I think it's distinct enough. Isn't finding T2 of X and T3 of X, what we've just done, different from that process? Because you do not need to know the nth derivative at 0. You just need to find the third derivative at 0 and stop there, because that's what you're being asked to do. So I think there's a distinct difference between a T3 of X and the full power series formula.
Yeah, I spent a lot of time teaching myself 11.11 this weekend and was very confused after coming out of Power Series.
Are you less confused now?
Yes, I am definitely 100% less confused, and it makes a lot more sense.
Okay, sometimes it's just hard to do something. You need maybe a little guidance, or whatever word I'm trying to find here. Textbooks are notoriously bad for using. You know, if you look at textbook, my experience is that they're very difficult to use to learn a new concept. They're okay. Once you know the concept, they're pretty good at, you know, refreshing your memory, because they're just telling you what you already knew. And you just needed to find it. Any other questions?
I have one that's kind of like a follow-on to his.
Sure.
So say we had a question that had us find the power series for e to the x, and then later on we get another question that has us do the e to the 3x. Can we just take our answer that we found in e to the x and apply it to the new one?
Yes, I would allow that, with one proviso. You have to say, using my answer to question 17, e to the x is equal to this. Now I'm going to use it to find e to the 3x. That I would allow.
Great.
I don't think I did that, but if I did, I could have been forgotten. Then that would be fine, because all you would be doing would be the same question, really, but with a 3 instead of an x. I don't think I've done that. I may have overlooked it. I may have actually done it and didn't even realize I'd done it. But yes, that is totally acceptable. You're going to find that you're shorter on time for this final. 3 more questions might not seem like a lot more, but there are very few 2 minutes and done questions in this final. So you're going to find that you're spending a fair amount of time on each. Now, if you know what you're doing, according to the little time thing I get, because when I pick a question, it tells me how long a typical student took to answer it, and, you know, the average time throughout America, I'm assuming. So I know that 180 minutes will work. So do the usual. If you really know that you're rusty on something, I would miss that question out until the end. You could spend 20 minutes on something and not be very successful. And you could do 2 good questions perfectly in that same time. You want to make sure you get that done. Lee, I'm just going to pick on you because I can. Any questions?
Not so far, no.
Oh, okay, that's good. I'm assuming that's good. Anybody got a question? We are pretty much finished then, if I have no more questions. Your time is valuable. I'll let you get on with it. I'll just repeat myself one last time in case you came in late or you missed it. In section 1111 homework, the only piece of the question that you're going to do is to find T2 of X or find T3 of X. If there's a B and a C to it, you're just going to write 42 and it's the third picture. And I'll sort out the homework grade accordingly, so you don't need to worry about that. And if such a question appears, and it will, there will be a question, find T3 of X in the final. If there is a R3 of X and a picture in it, you will also ignore those. And I'm only going to be grading according to the first piece of the puzzle. As far as I can recollect, let me look at the final. Are you looking at the screen? Are you looking at the white paper right now?
Yeah,
Okay,
the
so
paper.
then I can go in and look at the final exam then and not suddenly show you all. Okay.
Are there questions on the final from chapter 13 and 12, or is it only focused on chapter 11 and 14?
It's on everything, so yes, from those other sections there will be
Okay.
questions. I'm just jumping forward. Let's pick that guy. Come here. Right. I just want to make sure what I'm telling you is the truth from what I recollect, but it was late last night that I did this guy. Yes, you will be given a question where you're finding T2 or T3 of X. The only secondary part to that is to graph F and T3 on the same screen. I think you should be able to do that. I'm not going to ignore that. So, you know, in your calculator, you can put F of X equals E to the 3X. And then in Y2, you can put, you know, whatever it is T3 of X. And then you'll have a picture. And there's 4 pictures to pick from. So, yeah. So there's nothing that you need to miss out in 23. Let me check if they're in 22. Nope, that's good. And the phrasing that they use is use a Maclaurin series in this table, and this table is blue, and when you click on it, you get the guy. So that's the phrasing that they use. And I'm just scanning it at the beginning now. Yep, the first question is find some partial derivatives. Then we do vector stuff. Then we move on to space curves, velocity, acceleration, derivatives, normal, binormal, all that good stuff. Then we move on to power series, sequences and series. And that's it. Yep.
So
yeah.
Just to clarify your previous comments on the homework, we're on the homework itself, the thing due tonight, you're only caring, am I hearing you correctly that you're only caring about the Tn of X and not the Rn of X or the graph?
Correct.
Okay, just making sure. I was getting my streams crossed as to, you know.
Yeah, I just had to look at the
homework or
final.
exam.
Right. Yeah, in the homework, all you do is the T2, T3 of X then. You could do the graph, but don't bother. Just find T2, T3 of X. That's it. In the final exam, there is one T2, T3 of X question, but it has a part B, which is draw the, on the same thing on your calculator, draw the original and draw T3 of X and pick the picture. And I don't think I need to skip that because I think that's something you can do. I mean, I did it today, didn't I? You just put in the 2 and
Desmos, because as you're doing some of those,
Desmos
doing them
will
on
work.
Desmos over here, it looks very, very nice on that, even nicer than a TI series
Yeah,
calculator.
it's colored and got all sorts of cool stuff. And Desmos and GeoGebra, there we go, are both acceptable resources. You are allowed to use them. Anything else I could say about that? Do you know that you can use the fact that the calculator of the original